Hello, let's continue our Sudoku adventure with Sandwich X by PjoeterBliep. This puzzle was made for the September theme week, but didn't make it into that week, so we're featuring it now. Let's go over the rules. We have normal 6x6 Sudoku rules, which means in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have duality. The clues outside the grid are both X sum and sandwich clues simultaneously, so all of them are both. So these are individual constraints that you'll see in other puzzles, but these combine them. But we can kind of treat them separately and just assume the numbers are kind of overlapping clues. All right. So how do X sums work? Well, let's look at this 11 here. The digit outside the grid is the sum of the first n digits, and the n is the closest cell to the clue. So let's say this was 3. That makes n equal to 3. So we go 1, 2, 3. So these 3 cells, including the 3, are used to sum to 11. So we already have 3, which means that we need 8 more. So these 2 sum to 8. So we could do, for example, 2, 6. So these 3, 6 plus 2 plus 3, add to 11. That works out because this is a 3. If this were some other digit, like a 4, we would need to use 4 cells to add to 11 instead. And this would count as 4 already towards that sum. All right, we also have sandwich sums. Let's say this 11 is also a sandwich sum, so we'll use this same one. The 1 and the 6 are going to be somewhere in this row. Maybe the 1 is here and the 6 is here. And then, actually, let's put the 1 here and the 6 here. So now, whatever digits are in between the 1 and 6, not including the 1 and 6, whatever ones are in between them, need to add to that outside clue. So in this case, these 3 would have to add to 11. So we could do, I don't know, 2 plus 4 plus 5. So 2 plus 4 plus 5 is 11. That is in between the 1 and the 6. That would be our 11 clue. All right. And that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. Okay. Now, I think the 3 is a great place to start. A 3x sum can only be 2, 1. That's our only choice. If a 1x, just to be clear, a 1x sum would always sum to 1. It would use only itself. And a 3x sum already has 3, and we need to include 2 more cells, right? So the only option is 2, and then now these 2 have to add to 3, so that's a 1. Now, between the 1 and the 6, we need to add to 3, but we can't use the 1 or the 2 to add to 3. So this just has to be 3, then 6, and then this is a 4 or 5 pair. All right, let's think about the 6 next. So we can't use the 2. So this is going to have to be 3. Obviously 1 only adds to 1. 4 would add to at least 10. 1, 2, 3, 4 would be the minimum, and that's 10. That's way too big. So this has to be a 3. It is a 3 in the corner, celebrating. And then these 3 add to 6. We already have 3 and 2, so this is a 1. In fact, it's always going to be 1, 2, 3 in that case. So this is 4, 5, 6. This is 4, 5, 6. This is 1, 2, 3. While we're at it. Okay, so what about the 7 clue then? So we could do 2, 5 like that. That would work. If we tried to use the 3, there's a problem with x sum, with an x sum 3, with the 3 size x sum adding to 7, which is that 3 cells adding to 7 is possible, but only 1 plus 2 plus 4. You will note that 1 plus 2 plus 4 does not include a 3. So another way to put that is we already have 3 here. And so these 2 need to add to 4. How are they going to add to 4? Well, we can't do 1 plus 3. The 3 is used, and we can't do 2 plus 2. It would repeat the 2. So it's not actually possible to do 3. And then 4, again, maxes at 10. So this is definitely a 2 and then a 5 here, giving us 4 and 5. And then between the 1 and 6, we add to 7. There is no 7 digits. We need 2 digits in between the 1 and 6. These already aren't 1, 6. So these are the only 2 digits that'll work. So this is 6. This is 1. I'll clean this up a little bit. And then between that, hopefully 3, 4 adds to 7, which it does. And that's our 4. That's our 3. That's 5. That's 4. All right. Just cleaning up a little bit. Now, finally, 11. This can't be a 2. And you'd think 4 would be possible because 4 cells are minimum 10. But it has the same issue as 7. The only way to add to 11 and 4 is 1, 2, 3, 5, which skips the 4. So there is no way that you're going to add to 11 and 4. Here's another way you can think about that, which is if these 4 cells add to 11, we know the entire row adds to 21 because 1 through 6 adds to 21, then this has to make up the difference between 11 and 21. So this would have to add to 10. Obviously, with the 1 here, that's definitely not possible. But even without the 1 here, the only way to add to 10 is 4 plus 6 in 2 cells. but we already used the 4 here, so it doesn't work. So 2 ways to think about that. 5 is too big, and it can't do it anyway. So we're going to put a 3 here. That's 1. Now between the 1 and the 6, we add to 11. So the 6 can't go here, so the 6 is going to have to go here, because we can't do it in one cell, obviously. So this is going to be our 6. And then now we already have 3 plus 6. That's 9. This has to be a 2. 3 and 2. And then this should just work out. This is 4, 5. So that's 5, that's 4. So in between here, 4 plus 5 plus 2 is indeed 11. I wonder if my example was almost exactly what this ended up being. I feel like the 11 is very restricted in that way. All right, now we just got to kind of fill the rest of the puzzle in. This is 3. Oh, sorry, not 3. We need a 2 and 6. Down here, we need a 2 and 1. This is a 4. This is a 3. This is a 6. And up here, we need the 1. We need the 4. We need the 5. All right. Cool puzzle, PjoeterBliep. I enjoyed that. Really nice use of the limited xsum values, right? 7 is a really interesting one. 11's interesting. 3 is interesting. 6 is even interesting, especially when it can't be 2. So that flowed really nicely between them. Cool. Well, let me know how you did. And if you enjoyed this, why don't leave a like, subscribe, and a kind comment below.